So the concept for this entire session was actually came up in a Mingler conversation with Carolina and me when we were testing out Mingler for the conference. If you guys haven't tried Mingler yet, it's a really fun way to make connections and actually spawned this whole event that we're about to have. So Carolina noted to me that she faced a real challenge in her education space, which is she has scientists come into her workshops and they don't think of BioArt as one of the tools in their toolkit. They don't think of the creative angle as something they can infuse into their science work. So we brainstormed a little bit and we came up with this question that we're hoping everyone in this room can grapple with today. Why art for scientists or BioArt for scientists? And I'm actually going to turn it over for about 3 minutes a person to our 5 highlighted speakers who are each from very diverse types of educational spaces. And they're going to share with us one example from their community setting of how BioArt can enhance science education in their view. And they're also going to do a little bonus of introducing themselves and telling us about their learning setting. So we're so fortunate to be joined by some amazing folks in the upcoming session. So first, I'm going to hand it off to Carolina.
Hello, everybody. So I'm a bioenthusiast and bioartist, and I've been self-educating myself for the last 3 years in the realm of biology. And I've been conducting in Warsaw, or initiating in Warsaw, Poland, where I'm based, some events such as exhibitions, and also conducting workshops. And during and my experience is that I would say. Sorry, I'm very sleepy. That my scientist friends who were like circulating around the zone very often have misconceptions about arts and bioarts. They're just like thinking that it brings to the table more of the aesthetics issues, whereas it can be much more. And there are like I believe that there are like certain tools and skills and mindsets and creative approach that artists are very fluent with, and that can be shared and incorporated into science practice, which is going to build the field of bioart, but also I believe it can fuel scientific discoveries. So I didn't choose like any examples of a great pollination in my practice, but I chose like few historical examples, basically 2 historical examples and one. Yes, we can go the next slide. And I will very shortly say about it. So you can see a Micro Venus by Joe Davis and Oron Katz meet. Both of these works started, like the Oron Katz meet was in 2003, and then like several years later it was like being considered as something to be done as a product, as a food product. For Micro Venus, encoding in DNA data is also like being widely spoken today, and those are both like artistic projects. I also put here Kari Mullis, mentioned by Roland, who will be speaking later, and he's like an inventor of PCR, and I'm just like put him here because he had like a very creative mind and was like very prone to experiment, and he was crossing like scientific realms. So thank you.
Awesome, thank you, Carolina. Okay, Sarah, you are up for your 3 minutes.
Hi everyone, I'm Sarah. I'm an artist and PhD candidate in microbiology, and also I'm studying education at the University of Alabama at Birmingham. It's a research-intensive university in the southern US, Birmingham, Alabama. So I want you to imagine the worst, most boring science class that you've ever taken. In my case in college, I didn't really have to imagine that. It was most of my science classes. Most of them were lecture-based and very, very boring. But at the same time as that, I started getting into art classes and actually learned how to problem solve. So when I started graduate school, it was around the same time that the International ASM AgArt contest was introduced in 2015, which Sarah Can mentioned maybe an hour or two ago. And we started to realize that AgArt could be used to revamp some of the intro curriculums that were really lecture-based and really boring, to have students actually do science. So I built a curriculum, to the next slide, called The Art of Microbiology, where our students, undergraduates taking intro microbiology, could make AgArt from soil bacteria. And they do more than just the art, they also learn PCR, gel electrophoresis, sequencing, blast, etc. But we take it a step further, and instead of them just making the agar art and being like, you made a complete art project, they study the interactions they see in the dishes to develop hypotheses and about the interactions they see from their organisms. So the agar art then becomes a canvas for their own discoveries to answer questions that they're creating, and then in turn, they're teaching us, the TAs and the teachers. On the side, I've also shown with some educational data that students who use this curriculum versus the more traditional curriculum at our school, like the one that I went through, are more likely to call themselves scientists, and they're more likely to feel confident when they're designing their own experiments. At the university level, research opportunities can be really exclusionary. Like, it's really hard sometimes to get a position in a lab, but there are hundreds of students sitting in introductory classrooms waiting to actually learn how to do science. And that's why I think this is so vital to think about reform, pedagogical reform, using bioart and other types of authentic research opportunities in the introductory classroom at university. I keep on doing this because I don't want science to be defined by some of the boring experiences I had that almost drove me out of it, but instead by student curiosity and exploration.
Thank you, Sarah. Okay, we're getting a lot of stuff in the chat about chemistry. It seems like a lot of people had a similar experience with that class. All right, and we are ready for our 3 minutes on deck for Roland.
Thanks. Hey everyone, I'm Roland from Dierendonck. So I'm originally from the Netherlands, and I freshly moved to Norway because of love, actually, because my girlfriend was going to do a PhD here, and I'm very happy that I moved because then the lockdown came and I was on the good side of the border. So my purpose is to set up creative kind of high-level projects combining biology and media technology, because those are my two backgrounds. I studied biology and then I did media tech, which is a bit like the MIT Media Lab, but then in Leiden. And I found this whole world of do-it-yourself biology, which kind of bridges the two, and became active in that scene. So I did a lot of teaching as well to facilitate these kind of projects in others at Waag in Amsterdam. And also we had our own lab, Amsterdam Biolabs, and I used to teach at the Utrecht University of the Arts. I wish I had shown more pictures of my project here. I mean, this is just me, and so you see me twice. But you can see more projects on my website, which was on the previous slide. But anyway, it's just myname.com. And now for this one. Yeah, so what we bring to the table here in this discussion about how scientists can learn from an arts curriculum, or what an art curriculum could do for science, is I've been leading the Biohack Academy at Waag, where you see some pictures from here on the right. And the Biohack Academy has lectures on biology and bioart, a lot of guest lectures. Actually, Sarah Atkins did a guest lecture last time, which was great fun, about agar-art. And it's about how to design, build, and use your own biolab. So there's open source designs, and how to learn biosafety and learn microbiology techniques using selected BSL1, so biosafety level 1 organisms and protocols. And there's documentation, but why I put this here in italics is you can actually find all this stuff still on the syllabus, which is this link up there. So although kind of this course was not there online this year because of the whole pandemic situation. There's so much resources that can be used. And some pictures on the right I can speak about. This is one student project by Bart Peters. Bart Peters is an interesting example because he was an aerospace engineer, and he was kind of in a interesting phase where he said, I want to learn biohacking, and then he came across biotic games and slime mold. So he made this project, Can Slime Mold Play Pac-Man, where he built this, using his engineering skills, he built this robot to interact with, no, that's not a good link, wait, to interact with slime mold. Yeah, so for links, github.com bioacademy is the GitHub, but then the syllabus is https biohack academy .github. And also the documentation of student project is nice to look at. Actually, Georg Trammell in Japan always joined as an international partner labs, and they have the weirdest project in Japan. It's really great. And above, we did a CRISPR-Cas workshop from the Odin kit, which is illegal in the Netherlands. So we looked at the border of illegality. Oh, it's time. Anyway, that I put there because it got a Nobel Prize. Okay, yeah, done.
Thanks, Roland. Okay, we're ready for Amanda Obidike.
Yeah, so I'm here again. Okay, so my name is Amanda, and I shared in the last session that I'm from STEMi Makers Africa here in Nigeria. You can see Nigeria on the map. So outside of championing STEMi Makers Africa, I'm also a data scientist. I'm a STEM advocate. I love talking about STEM to people because I see the effects of STEM in other countries, and it's something that I desire that Africa or Nigeria will start working in. I'm also a community mobilizer. I go to marginalized communities. I try to do some training and onboard them on STEMi Makers Africa's platform. So, as a data scientist, I'm also passionate about the underrepresentation of women and girls in STEM. So I usually take out surveys and a lot of findings just to ensure that girls in marginalized communities, especially in the northern region of Nigeria, which we get to hear about. I don't know if you've heard about Boko Haram, this terrorist group, depriving young girls of going to school, not to talk more of, dreaming to be engineers and all. So we use this to, talk to decision makers and politicians just to ensure that we have an inclusive environment where these girls can think. They should be free to dream. They should be free to succeed. So yeah, that's just a little about me. Then how we began STEMi Makers Africa, I think you'll see it in the next slide. So I don't have a background in science, although I love biology in secondary school. I was one of the best students, but I don't know what happened. I was just this disconnect. Maybe my my teacher left the school, so this passion wasn't there, and also I just had to delve into accounting. But sooner or later on, I found out that I really need to trace my roots back to biology. So what we have really experienced and is existing in our institution is science, biology is usually lecture-based. It's so theoretical, it's so boring. So there is this excitement is not there. So what we do in STEMi Makers Africa is we try to ensure that students are critical thinkers, students are curious. So we in our lab, we have these 3D printers and CNCs where students can ideate, students can think on something, and students can also produce that. Then, outside of the innovation lab, in marginalized communities, we tell them on how they can use disposable items, recyclable things, just to ensure that they can bring whatever they are seeing as a diagram on their textbook, to real life. And we find out that is really, really exciting for them. It's a long-lasting perception that they have for biology and science. So that's just that about us. And yeah.
Thank you so much, Amanda. Yeah, some of us have to think about, materials access, and some of us have to think about Boko Haram. So there are constraints everywhere to everyone's biomaking. Thank you so much for sharing that. Okay, so we're ready to move on to Carolyn, yet another completely different setting.
Yeah, hey, I just want to do a big +1 to Amanda's comment, free spaces for women to think and dream. I think that's huge. I work in the context of a community college, a biotechnology program right now. I'm actually a student in that program. I come from a fine arts background, getting a BFA and MFA, and teaching, and then coming back to school. So I'm showing a picture of my two collaborators here, Dr. Talene and Dr. Kubo, who work as biotechnologists at the community college. And what we've done is to form, it started as a Friday afternoon club where we would come and do, in essence, high-level collaborations between scientists and artists. And we worked on a couple of projects that are attempting to really use biotechnology as a tool to do art. And one of the ones we've been working on currently is something called rendering a biosynthetic carotenoid pathway. And we're trying to genetically manufacture the gene elements, the gene pieces that are necessary in order to create this pathway that goes from white to pink to yellow. It's been a very interesting process to work with these people because you have to start by explaining what the art concept is, have them think about what the science concept is, and then do a series of iterations or progressions along that idea. So this has been a really fun experience within the context of a workforce training program at the community college levels. That's the place that I found access for this kind of work. And we can go to the next slide. Couple things I want to talk about here. What's the future of biotechnology? What's the future of multidisciplinary programs? And I want to say several things here. It matters who's at the table and who has access to biotechnological science education. Who can get in those programs? Who are your students? Secondly, it very much so matters who are the instructors in those programs and how do they welcome a diverse student body. Thirdly, multidisciplinary education creates social and creative contexts that ferment change. And on the right there is a picture of another community college I've taken classes at, Solano Community College, where they have a very direct outreach to the minority and underrepresented communities and bring them in for workshops into a fairly advanced biotechnology space. And lastly, I cannot speak without acknowledging a 2020 Nobel Prize of Women in Science, and particularly the ones that have not been recognized and have had patents stolen from them, now getting that recognition. This is huge, and it has a huge relationship to the context of education and whether women are taken seriously in a science realm. Thank you.
Amazing. Thank you, Carolyn. Sorry for the slide slip up there. So before I get into the Miro board breakouts, I just want to summarize. So thank you to all of our speakers. And actually, we're about to engage a little bit more with them. So you get to have a little bit more time with them in addition to some time for Q&A later on. But part of the reason we drew this crowd together, in one sense, it's to highlight all the amazing work that's happening in the BioSummit community, which is usually the case. But in another sense, we're sort of all thinking about education coming at it from different ways. But as we were planning the event, we were kind of thinking about how we all converge on a few really core, we think there are probably some shared ideas that are important for bringing bioart into bioeducation. So if your pedagogical approach differs, some people take more of a hands-off approach where they let sort of, almost like a garden approach where you plant your seeds and sort of see what grows without touching it too much. And other people take more of a structured schedule approach where you have a very specific cookbook amount of activities you have to get through. And there's, balance to each of those approaches and to things in between. But what we were hoping to do now is to sort of think out loud with all of us in the audience and the speakers about what are the connection points, the junctures between all of these intersecting threads of the work in bioart and bioeducation that we're doing. Where do we need to coalesce to make sure that BioArt gets into bioscience training in a way that gives everyone sort of the same sort of foundational knowledge, practices, skills, experience. So we're going to try something a little experimental. I don't know if all of you have tried Miro board yet, but we're going to try Miro board. And I also don't know if you guys have tried breakouts yet, but we're going to try breakouts. So there are 2 opportunities for this to explode, or twice the opportunity for it to be amazing. So what I'm going to go ahead and do now is just demonstrate quickly how the Miro boards are going to work. And then actually we're going to hear quickly from 2 sort of guest expert Miro moderators who are going to be in the background reading the things that we're doing, making some connections, and figuring out if there are threads that they can sort of synthesize and pull out from everything. So first I'm just going to pop into the Miro board breakout. So if you see this link here, actually Mackenzie, I wonder if we can drop that in the chat, or if you've already done that. Just follow that to the Miro board website and you'll type in microbes rule. So I'm going to stop sharing this screen and share my Miro board that I have open over here. Or maybe I'll keep sharing that. All right, let me try that one more time. Sorry, guys. It really doesn't want me to take you to this Miro board that I have open already. All right, so I'm going to go ahead and just paste it in, and you'll see how I have to type the microbes rule password, just like when you're logging into the website. Oh, okay, I guess it was logged in for me. So is everyone able to access this? You can shout out in the chat if you're having trouble. I see a lot of people logged in, so I think that's a very good sign. So what we're going to do is we'll in our breakout rooms, we'll each take one of these areas to focus on, and you'll also be paired with one of our 5 speakers that we just heard from. But before I launch into that, I also want to introduce our guest Miro editors, so our moderators, if you will. So let me go ahead and pull up their slides while Ipsa and Shrestha get ready to introduce themselves. Hopping around all over the place. So take the time to make sure you're in Miro. If you haven't used Miro before, maybe try typing a little note, just get used to that interface. While I scroll to slide 100 of this deck. I'm not sure where that feedback is coming from. It might be one of our speakers, but for now, I'll just let Ipsa quickly introduce yourself.
Thanks, Amanda. Hi, I'm Ipsa from Bangalore, India. I'm a freelance science communicator, and I use drawing as a way to explore science. So I do a lot of workshop with aspiring scientists and scientists in training, and work with them to use drawing as a way to hypothesize and explore their hypothesis. And I'm also a zine maker and a STEM picture book maker. And my hope is to have zines as both as a medium of communication and also as a medium of assessment in classrooms. So I do a lot of zine making workshops where students get to engage with ideas and then retain those ideas while building stories around what they hear and learn. Yeah, thank you.
Thank you, Ipsa. I'm so sorry. I think my computer is reaching the max capacity of tabs I can have open, so I'm having a little trouble presenting and projecting, but we will show your photo in another moment. And then, Shrestha, do you want to introduce yourself as well?
Yeah, sure. Hello, everyone. Shrestha joining in at the middle of the night from India. So I'm going to explain a bit about my work with my team. So starting lockdown in March 2020, my team and I saw that children were being most affected by the sudden change in normal settings. But nobody exactly in the adult world was talking about them because we ourselves were lost. And that is when we realized that since already STEM education, at least in our country, as it is, was very, very restricted to textbook knowledge that has not been updated since decade. And now it was even more restricted in Zoom classrooms. So with our initiative with the younglings, what we did was we tried creating STEM newsletter and some engagement in directions of magazine for young kids, so as to incorporate other means of STEM education. And now we are trying to put towards integrating more of art while delivering that those STEM concepts. So yeah, that's it.
Thank you. And I promise we will show the slides that Ipsa and Shrestha prepared after we do our breakouts. Technical difficulties over here. So now I think we're ready for Janice to go ahead and break us out. We have enough participants that I think we can just do 5 breakout groups, one with each of our speakers. And then Ipsa and Shrestha, you can be bouncing around between groups and also just reading what happens on the Miro board. So within your 5 groups of speakers, why don't you, let's see, why don't you each take one question? I'll let you sort of pick amongst yourselves which question you want to tackle, and with your group start brainstorming out answers or just whatever comes to mind as you sort of percolate on that question. So now actually we have some time for Q&A, and I'm going to give Ipsa and Shrestha a little time to do some of their behind the scenes magic of sort of parsing through what all we wrote and figuring out if there's anything that kind of like synthesizes a lot of our talk. But they have a few minutes to do that, while instead we take some Q&A from our speakers. So Janice, actually, do you think we can get a spotlight on our 5 speakers?
Yeah, working on it right now.
Thank you. Can we all just throw some love at Janice? Janice has been here since like 8:30 this morning, since 1:30 p.m. my time. So that's coming on 7 hours or something, 5 hours. She has been tirelessly helping us set up the tech stuff, and we saved the hardest session for last. She is a rock star. Thank you so much, Janice, for all that you do.
Not a problem. I've been enjoying a lot of the talk, so that's good.
All right, so we're starting to get thrown in here. Does anyone want to, I don't know if we can unmute ourselves, but does anyone want to unmute themselves and pose a question to the group now while we're getting the spotlight sorted out? Or you can type it in the chat if you prefer. It could also just, instead of a Q&A, it could just be a general question that you want to keep the conversation going, because I saw a lot of really interesting stuff happening in the Miro board.
Maybe I'll throw out a question to my fellow panelists, and that is that we've all talked about some really different venues in which art and science research takes place. And does anybody have opinions about what are some of the more successful venues? Like what are different levels or different places that you feel like art and science belongs and has a chance for success?
I think the Bio Summit is a really good venue for this kind of hybrid form of research.
Do you think like within the traditional university system, do you see it as a very successful model or one that's used much? Have people found that or not? Or is it more of a one-off kind of thing that we do individually?
Well, to be honest, it's a really big question, so I find it really hard to answer. But at least from my experience within Europe, you also see like big differences. For example, in the UK, there is also more tradition of, for example, art-based PhDs. So people kind of continue on this path, combining art and biotech, maybe even after high school and college, but then in the Netherlands less so. So it's really regional, I would say. What do others think?
I feel like this kind of in the university context, it's more common. At least I observe it in the Western Europe and in United States. Like, for example, in my context, this kind of presence of bioart or biodesign still is very new in the context of academy. And I feel like academies are very slow here to adjust to the needs of the modern world. So like Copernicus Science Center, with the educational institution that I was collaborating with on several occasions, this is somewhat like faster reacting entity, but still it more addresses a very young adults. So like the high school students and university students are not in the circle of their main focus. But I would like to see more of this kind of work in the academical context. I don't know if it's doable and how, but I hope it is, and it will be here more present.
I wonder if Amanda O, if you have a similar experience or a different one from the perspective of teacher training.
Well, yes, in Africa here, we're pretty slow. Everything is so slow, you know, because even in the universities, it's not even integrated. You know, there is this disconnect. And for example, we launched this virtual lab on our learning platform, and it was really, really difficult for these educators to navigate through. And it's something that we felt is something basic that they can, you know, explore or get well integrated in. So it's about the system. You know, the system is not really reformed enough that teachers can be refined. So you find out that you're doing a lot of work just to train them, onboard them, then they can onboard their colleagues and onboard students. So it's an issue here in Africa, but we're looking at more ways that we can, you know, integrate bioart into classrooms and into, you know, learning management platforms. So yeah.
Awesome. And I think we're just at time. So in the last 1 minute, I'm gonna rapid fire. First of all, thank you so much again to our speakers for being down to clown with whatever the format of this session was. And I'm gonna go ahead and share my screen one last time to the currently being edited slide where Shrestha and Ipsa, why? Okay, is it showing you guys my slides? Okay, good. It always bounces to the wrong screen for me for some reason. But here's what they came up with for our key takeaways. I don't know if you guys are able to unmute yourselves, but maybe Ipsa, do you want to go ahead and call out some of the things that you highlighted on this slide here?
Sure. So lots of interesting thoughts and discussions happened on the mirror board. And one of the key things that we noticed was a lot of things about cross-pollination and inquiry and playfulness and interdisciplinary ideas that can happen in such spaces where art and biology are sort of coming together. One of the challenges was that there is a need to identify time and space to be able to do that if it's happening within the curricular spaces or academic spaces. And there's also a need for them beyond academic spaces. I'll let Shrestha cover some of the other points. Shrestha, are you here?
Yeah, sorry, I was muted. So I was going through some of the other my robots, and I think the first point was well covered by Ipsa already. Some of the other insights that I sort of saw that was that has been the recurring theme of all the sessions that we have been going through in this track is that if bioart or science art is to be integrated into science education, it has to serve a purpose in people's lives. So the more we have project-based learning where art is integrated with science, the more effective it would be. And yeah, and this would also require integrating some amount of skills, prepping people up with some amount of art skills, and augmenting their STEM training with art would be the way to go. So yeah.
Awesome. Thank you guys so much. I actually feel like you pulled out some of the themes that we've been talking about all day here in learning and education, with primacying relevance and making sure that it's playful and sort of making it not feel like school, if you know what I mean. So thank you guys so much. And here, once again, I'm just going to highlight, this is the slide I couldn't show before, but Ipsa and her amazing work. And you can follow her at Ipsa Wonders. And Shresta's great work at the Younglings. Shresta, maybe we can go ahead and put some of these slides into the Slack for everyone so that they have access to seeing what you guys work on and what you do.
Family photo?
Oh yeah, family photo. Sounds good. We don't have a chat monitor anymore, but here's all the contact information for everyone. So you can take a quick screenshot if you'd like to contact them. I'll leave it up for one moment. Okay, screenshot captured. And thank you again so much to everyone. Oh yeah, one last call out. There's a follow-on session to this that we will promote more in the Slack, but tomorrow at 3:20 p.m. Eastern, we'll be doing, well, Carolyn really will be doing bioart and design with co-creating the field of bioart in a 3-tiered session that I wish we had more time to let her share on, but she can stay on and address any questions after our family photo. If we want to quickly say cheese for the camera. Ready? 3, 2, 1. Bio Summit. Moving to the next slide. There's a lot of you. 3, 2, 1. Bio Summit. Awesome. You guys are so forgiving. Thank you so much for joining us for this silly and playful session. And thank you again to all our speakers, all of our expert chat moderators. You guys are the best, and I can't wait to keep thinking and learning with you all weekend and beyond. And now I think we all have 5 minutes before we turn to the plenary session again. Thanks, everyone.